we go. So one thing I want to talk to you about is, number one, the NEC 2020 was introduced into the Texas legislature this year and is actually effective um, with the provisions of those voting. That does not mean that every municipality or every code official will be requiring um, the situation will be requiring that you follow or that the electricians in the area follow. Again, my background has been in contracting. I've been in the industry, contracting industry, for a number of years. I can remember back to 87 and 88 when the Texas Real Estate Commission first offered real estate licensing. I was able to get my certification at that particular period of time. However, going through that and going through evaluations with the insurance agency, I continued on in the contracting and have been focused with that since that particular period of time. Now, I am an electrical contractor and I try to stay up as best I can with code. However, last year, the last code revision 2017, which we talked about, along with this code revision 2020, is over 1,000 pages. So therefore, as an electrician, basically what you really know is what you're involved with every day with the code. And you have to refer to the code periodically when you get involved in things that you haven't been experienced in or evaluated. So keep that in mind as we move forward. I know Derek did a wonderful job previously with answering code questions and being able to let you know what he goes through as far as the code is concerned. I'm not going in that direction. Again, mine is about the NEC 2020 and the updates. Now, I can't cover all of them simply because the code revisions in 2020 probably have been so enormous that this has been the largest code evaluation changes that I've been involved with since I started doing electrical work in 1965. And I can remember the code book back then had maybe 100 pages to it. I checked this time and it's approaching 1,000 pages, so you can imagine. So our objectives here are to differentiate the changes of the NEC 2017 till now. There's a lot of things that have happened in the past. I know Derek talked about those. I'm not going to expound on those. I'm only focused on what the big stuff that you're going to have to be looking for in the coming years. And basically where these come from is new construction. Significant changes, as I say, I'll reiterate. Now, if you notice at the bottom of this, it was enacted by the state legislature, Texas state legislature, in November of this year and became active. But as Derek has said, as Derek pointed out, as I am familiar with the code here in the Tyler-Smith County area, they're just now coming in and enforcing the 2017 code. Derek, I think, mentioned the 2014 code and a lot of things that he did, but we have to be careful and we have to really point out the deficiencies as well as make critical notes for customers. Probably the most dangerous, if not to a life or property damage. So therefore, it is critical that we get as much knowledge as we possibly can. Now, I do not have and cannot interpret what the authority, AHJ, authority having jurisdiction, that is a particular person. And I know having worked in 5 states, even in the state of Texas, there's a lot of misinterpretation or different interpretations between municipalities, even as close as Smith County to the next county where I do most of my work. The inspectors don't agree on everything. So we have to be very careful how we interpret it. I just got through with a job 2 weeks ago where it was a blatant foul with a code as long as I can remember, where all of the neutrals and grounds, there were at least 2 to 3 under each lug. So therefore we had to call it out as a deficiency and go forward. So these are the expectations, but don't be surprised because there's big things coming. There's big things happening. So with that, let's get started. And we'll start with the first article, which is the definitions. And I have a code question for you. It says installations supplying blank power to ships and watercraft and marinas and boatyards are covered by the NEC. And your choices are shore, primary, secondary, or auxiliary. I'll give you a little bit of time, just a few seconds to think about that. I don't expect you to respond. I'm going to give you the answer in my next slide. Why this is important? Why is this a big deal? It's because in the last 10 years, there have been a significant increase in water deaths, not from drowning, but actually the occurrence of drowning, which was actually what killed the people. There was electrical current in the water, not enough to shock you, not enough to feel like you're shocked, but it put your heart and your muscles in a relaxed state where you couldn't swim. So there have been many people die from this. So it says the answer to that, if you want to jot it down, is shore power. So in the last part of this presentation, we'll spend a lot of time on shore power because they have completely modified the code and actually given this the importance of a second chapter, if you will, or its own division. So we'll move on into Article 90, some of the big things that as far as the definitions and practical application is the code is not intended as a design specification. I tell all of the people that I talk with, this is not, it is the minimum standard as any code is in the U.S. The minimum standard that can be presented, it is not a design guideline, nor does it eliminate or prevent a contractor from doing a better job. Again, this is minimum standards, and some people fudge on those minimum standards. And of course, the other point that I've made, and I've made it before, is the 90.4 is where the authority having jurisdiction, the AHJ, has the enforces the code and interprets the code. So if we disagree, basically what I have to do as an electrical contractor, I have to present the code, and even sometimes I have to go to NECA, National Electrical Contractors Association, to get help as far as the interpretation, because how I read it and how the electrical inspector reads it is two different things. So keep those 2 points in mind. It's not a design manual, and the authority or the inspector in the area or the code official in your area is a person with the authority to interpret the code. Okay, so 90.2, section 90.2A5 is establishes electrical short connections watercraft, Article 555. This is basically a new article, and they're expanding with the electric vehicles. We're starting to see a lot of this now. On not only charging, but at a private residence, an electric vehicle is actually allowed to charge the residence. So it's exporting the power. So this is something that's going to be totally new for us as contractors and as inspectors. Now you're seeing these devices that will allow in 2020 to allow that vehicle, if it's fully charged, to be able to send power back into the house to the inverter in the house. And of course that's makes it tough because a lot of things that we're having to keep up with that takes a lot of our time. So in chapter 1, general provisions, we have the just the blanket. This is what I'd like to have when I'm teaching people the National Electrical Code, is spend the most time, because this is just general things that cover everything. But this is a question for you. Fault current is the current delivered at a point on the electrical system during a blank circuit condition: a short, excessive, induced, or over. So the answer being, fault current is the current delivered at a point on the electrical system during a short circuit condition. A short circuit condition is any time that a ungrounded conductor is shorted to ground or earth ground, or one of those devices. It could be to the box, it could be a number of things. So, but it is a short circuit condition. Okay, definitions continued, divided into 3 sections. This is the first time they've had to go ahead and add section 3, which is the hazardous locations. Now, there's been a lot of controversy, a lot of conversation, and a lot of code panel arguments as far as grounding and bonding. I just want to say this, as far as I'm concerned, whatever is metal in the structure, whether light commercial or residential, because I deal in both of those, it must be grounded. And one key point I want to bring out that Derek brought out during this particular segment or the slide is, just because you have rebar in the slab and it is in contact with the ground, if it's isolated, insulated by insulation or by poly or some material that's keeping the concrete to interact with the soil, you don't have a ground plane. So therefore, in this particular point, you're looking at a bonding of the ground rod, electric grounding conductor. You're looking at a bond from the column to the water pipe. And keep in mind, that must be a metal water pipe, either the galvanized copper water pipe, and it must be in touch with the earth or at least 20 feet according to the code. You can also have a bond to the grid, the structural steel that's in the concrete. Some people refer to that as the U for ground. And then they're talking about a ground ring. There's a lot of controversy in commercial buildings about a ground ring because, and I don't know if any of you get involved with commercial buildings, but in the larger commercial buildings, you have an extended, what they're requiring is a 2 AWG copper ground wire completely around and tied back into or considered grounding electrode conductor. So these things go back into the panel, and there's a lot of misconception here of whether this is a main panel or whether it is a sub-fed panel. So again, we've divided, the definitions have been divided into hazardous locations. These are some of the definitions, just a couple of definitions that come up with a lot is equipment grounding conductor. And people misunderstand that. That is not the earth ground. It is not to be connected to the earth ground, and it is a part of a effective ground fault path. And so everything metal, gas pipe, and gas pipe, you've got to keep in mind, gas meters in homes, especially with the rigid pipe, the Schedule 40 pipe, has to be, you have to sometimes put a loop around that gas meter. As far as an electrician, you have to watch for that because the gas meter is connected with rubber washers to seal from having gas leaks. And so that isolates the ground, the connection to that. But running a ground rod to the water pipe. And of course, now with PEX water, you've got to have a different type of setup because you don't have the grounding, you don't have the bonding capability to the water pipe. The new thing that we'll be talking about a little bit later is the fact that the CSST, or the stainless steel gas pipe, their bonding that's happening in the out in the construction sites is not going like it should. I had a job that I inspected last month where the plumbing contractor had actually, in a 2-story application, had actually secured the CSST pipe running through the joist. He had actually secured it to the bottom of the subflooring. And that's, if you realize there's going to be hardwood flooring or some type of flooring on top of that, they easily drive a nail through that. I've had other people, we have many incidences where fires have, many reports from the National Fire Protection have said that it's increased fires by 30% in just that category. So there's many things that paying attention to that and understanding what the code's trying to say is this is a much used area of the code, is the Article 100, which are all the definitions. Now, what has happened with the code is in the revision, a lot of the stuff that has that was used to be definitions like nursing homes and hazardous conditions and so forth, the definitions were there. What they've changed, the attitude of change, was that if the definition is repeated in the code more than 2 times, they've taken it away from that section or that chapter or that article and have moved it into definitions. So you'll start seeing, if you follow the code, you'll start seeing more definitions into Article 100. So here's some condition messenger wire. Now, if you want to, I've got my contact information. Trying to take notes on this is probably pretty difficult. So if you're wanting to, I have this information available to you if you want to download it, and Paul or Brenda will have it available if you want to do that as well. So fault current is the one thing is during short circuit or ground fault. So ground fault is where a wire goes to ground, being one of those other wires like the bare copper wire where the GFC of the ungrounded conductor shorts up against it due to pressure or whatever. And so a device may be giving up, broken, or something of that nature. Anytime that the ungrounded conductor comes in contact with a grounded or bonding conductor, that's when you start having that. Fault current is available, short circuit current and short circuit current. Habitable room. This is a little bit of change in the code where they've defined a room is in a building for living, sleeping, eating, or cooking. So that's a habitable room. Bathroom, they added the content. So in other words, to qualify, and Derek mentioned this in his presentation, so the sink has to be in a bathroom if it's qualified or considered a bathroom. Well, it's very important with the types of plugs and the type of protection that you have in there, both fixtures and plugs and switching. So that's a new added thing that they put in there this year to qualify that a bathroom has a commode and a sink or some other device such as a shower or something like that. But it has to have those 2 devices to be classified as a bathroom. Otherwise, it's not a bathroom, so the code doesn't pertain to that particular element. EGC is equipment grounded conductor, and it is not considered the grounded conductor. Grounded conductor terminology is the neutral coming from the service provider. In other words, it's connected at the transformer, either ground located or off of the power pole. The grounding conductor is the neutral. The equipment grounding conductor is the bare wire, or in some cases it has to be the insulated wire, and it has to be marked with green or a white stripe. I mean, a green colored wire, or marked with tape, depending on its physical side. Grounding conductor is a circuit conductor intentionally connected to the earth. So anything like that, the equipment grounding conductor, the grounding electrode conductor, those are two different wires. You can't have both in the system. One wire taking care of the duties of both of those. And laundry containing is designed to contain a laundry tray, a clothes washer, or clothes dryer. It doesn't have to have all of those. It just has to have at least one. Service equipment definition is updated to clarify where the utility ended and the feeders began. I'm going to spend a lot of time on that here in just a few minutes, in a few slides, because we have to very clearly identify as electricians, and also your understanding as an inspector, that the service entrance conductors in as a specific spot, and the feeders pick up from there. And of course, Derek had mentioned that in his as well. This is just a diagram, a little complicated diagram, but it helps starting with the defining. If you will notice, the labeling it here is the EGC, as equipment grounding conductor, is transferring is bonding everything together all the way back to the service. This is a service entrance conductor. It has a remote transformer. It has a main disconnect, and then the panel. The other thing is a GEC is a grounding electrode conductor. The grounding electrode conductor is this, where it's tied to the steel or the rebar or the UFR, wherever it's allowed. A bonding jumper is where we jumper from, like a terminal strip that's in a panel or the main disconnect. You bond to the can that it is mounted in. So everything is ground neutral. And basically, if there's a fault, like it shows here in this panel, if there's a fault, then whatever fault it is, if it's on the metal, then the bonding jumper is going to carry the fault away and protect whoever gets in place of it. And we have system bonding jumper, we have system supply bonding jumper, main bonding jumper, and neutral. Main thing you need to remember in this is the fact that you're bonding all your metal parts, and you're using that with either the equipment grounding conductor or the grounding electrode conductor, the bonding jumper, and so forth. Now, most of this stuff, if it's screwed, if these little wiring strips or terminal strips are secured to the panel, then that's gonna be bonded well enough. So either way, but keep in mind, here's a point. I run into this a lot, where people, electricians, will go in and put an extra grounding strip in here, or they may have to add one to separate in like a sub panel. They may have to separate the neutrals with the grounding conductors. They use sheet metal screws. That is not allowed. It has to be a certain national thread size and a certain torque and all of that. So if you see a sheet metal screw holding one of these items or one of these components in place, then that's a definite deficiency, because you can, as we see with many things, you can lose a ground and cause a safety issue with that. Article 110 is electrical installations for conductors. Now, in this presentation, most of my material, especially where it's underlined or highlighted, is going to be the specific change. So in other words, the words that we have here, the descriptions that we have here, unless they're underlined or highlighted, they're typically not changes unless the whole slide incorporates the change. So in this particular thing, the code panel is added back in copper clad aluminum. And so you can use copper, aluminum, or copper clad aluminum. You have to be careful because there are limited uses. So you have to go into the article 200 to be sure that you get that, those things listed where they are. Cables and conductors installed and exposed on the surface of ceiling sidewalls shall be supported by building structure, or not, and not to damage the conductor. And of course, these are code references for you if you want to use those. And basically what it means is when we're mounting when you see a panel mounted on a wall, basically what the recommendation by the National Electrical Code is that doesn't mount to concrete. And why that is because of the moisture that's conducted through concrete in whichever direction it may be. They want you to isolate it with wood or plywood, something of that nature. So anyway, again, that's a code official judgment call. The electrical connections torque rating. This is a big one for this year. Up until last 2017, 2014, it's always mentioned that there's torque rating on the screws that holds the wires and conductors in place, and in some cases breakers. Now we have to, as electricians, we have to torque these, and we have to show proof that we've torqued them to the point. In fact, you're going to start seeing in the new panels that manufacturers are building that the screws will have the torque rating on it, or will have a label in the panel showing what the torque rating should be. And it's supposed to be a mechanical device such as a torque wrench, a torque drill, or shear bolts, where everything is tightened down to that, because there's been a lot of incidences with fire and also death, electrocutions, because of loose connections. So, and of course, we'll be talking about some disconnecting mean changes. Okay, I'm going to open it up for any questions. Do we have any questions at this particular point?
Yes, Raymond, you had a couple of questions. Is a bonding jumper required on gas water heaters and gas furnaces?
Repeat that, please.
Is a bonding jumper required on gas water heaters and gas furnace?
Yes, it is. And that's usually handled with a dedicated circuit. Now, if it's not, then yes, it will have to have. And I know we've had issues with that in the past where people have had generators attached and there's no grounding on the generator, and people were getting hurt with that. So the dedicated circuit, and that's called, they refer to it as water heaters, and gas furnaces, they refer to it as fixed appliance. That has to have a dedicated circuit with a bonding wire to it.
Okay. I'm going to read another one here. No, it's just a comment. That's all the questions we got, Raymond, so you must be answering all of them for them.
Evidently, I'm doing a great job, right?
Absolutely. Keep going. Thank you.
I look forward to it. Thanks. Okay, so moving right along. So this is another question for you. And an existing installation where a voltage system or systems already exist and a different voltage system is being added, it shall be permissible to mark on the old system voltage. For many years in the code, we've been able to go in to modify a building and pull some wire in the existing conduit. And I know this deals with commercial more than it does residential, but we've been able to label or tag or something like that. What electrician would do would tag it or bundle it or use a tie wrap around it and label it. And they say that that's not permissible. And there's a code section reference to that. that you can't do that any longer. You may be able to pull, if the conduit fill, you may be able to pull the wires in there, but you're not supposed to, have two different voltage systems. In the older code books, they typically separated 600 volts to ground or less. Now they've revised the code book to go up to 1,000 volts or less. So that's a dividing point as far as the lesser code or the residential type applications and so forth. And of course, many things are changing in the residence. It's really going to cost electricians or cause electricians to have to increase their price. But it's also going to cost the inspector, they're going to have more things to be able to look at and talk through. So this is something we have to be careful about. So Article 200 deals with wiring and wiring protection. In other words, Chapter 2 has all the 200 articles in it, and I'm concentrating on these new ones. And you may not see a lot of this because it has to do with plugs and switches and so forth. But if you remember last year, or the last presentation when I talked about the 2017, the neutral had to start being brought into the switch box. And unless you have some reason to pull it out, you're not going to see this. But the neutral is, since 2017, we're supposed to be wiring the neutral into the switch box and not at the appliance or the fixture that's in the ceiling or wall. So now what they've done is they're color coding. They not only have to, the screws have to be a different color on the polarized plugs. So now they've added in, down at the bottom you see in section 200.9, they've added the word silver. So if you've noticed, duplex receptacles are just single point receptacles. The neutral and the ungrounded conductor, or the grounded and ungrounded conductor, have different screws. Typically the ungrounded conductor is a brass colored screw, and the neutral or grounded conductor is typically a different color screw, and this is the silver color, or you have to label it otherwise. So some way that they're changing this, where now the receptacle or device manufacturers are having to make those changes if they haven't already made them. Pet washing. This only applies to the commercial side, where you're seeing all these pet stores, and they're often pet grooming and pet washing and shampooing and foo-foo and so forth. They are allowing the pet washing areas in homes. You see those a lot being designed. This is the picture of one that I received from Derek, sent it to me, and it's getting to the point to where bathrooms are now, they're adding a second shower, which is typically an open shower for a pet washing station. So we have to go, these are going to change the way that the GFCI is protected or portrayed, and where you have to install it, because you've got significant, you're calling a wet area or damp area as far as the definition is concerned. A wet area is one like a patio, an open patio, where you may have plugs out on that patio. The other one is a damp location, where it would be something that's underground, like a basement, a crawl space, or something of that nature. So that's a general consensus. Now, we can get into the definitions all day long, which code experts do and argue point, but that's basically the damp versus a wet location versus a dry location. So I want to give you a little bit of information. I know you've probably seen this before, but I always like to go through it, because there is a difference of GFCI breakers and how it measures current, and a arc fault breaker and how it measures current. And this is something that's been misunderstood by a lot of people. But a GFCI basically, if you'll notice where the yellow circle is right here, that is a CT. Now, all a CT is a core of copper wire that's wrapped, and it produces a current. As current flows through the wire, it produces a transformer type current, and it goes to the circuit board. And if it exceeds, if it's 6 milliamps or more, it's going to trip. You have to be careful because there's a GFC, a GFPE, which is an equipment, and we'll be talking an equipment protection, which is rated at 30 microamps. So that's the two differences. And the 30 microamp is rated or can be used on shore type equipment. So we'll talk about a little bit of that toward the end of the presentation. But I wanted you to see that because if you took an amp clamp, and I'm sure every one of you have some type of voltmeter or amp clamp, if you took a amp clamp and clamped it around both wires, and you see a difference in that. In other words, if you took 120 volt and you clamped it around the white and the black wire with an amp meter and it sees 1 volt, you have an imbalance of 1 volt there that this device will pick up. And that's a quick way of finding it. And I'll show you another way as we go through this. But that just gives you an idea. This is a power, this is the ungrounded conductor, this is a grounded or neutral conductor. So basically, electrical theory is whatever amperage or current is flowing on the grounded conductor, the same amount of current should be coming back on the neutral conductor. And if it's not, there's a difference between the two. That means you have a fault or ground or leakage somewhere. So that hopefully that'll help you in the future. I know I use it a lot when I check neutral imbalance or I check a circuit imbalance. That's my first check before I hook up a mega ohm meter or some kind of recording device. And the more complex these breakers become, the more testing you have to do. I know I've got a house here now with arc fault in it that they'll start failing in 2 years, and I have to end up converting them to some other method to be able to keep the circuit from tripping every time you turn around. So these are things that we have to deal with. So Article 210, branch circuits. This is the first time in the 2020 code that now GFCI in a dwelling unit, this is residential type dwelling unit, single family, multifamily, all 125 to 250 volt receptacles have to be ground fault protected in particular areas, especially those appliances, for example, a stove. We talked, the previous presentation talked a lot about the 6-foot rule. A lot of stoves are within 6 feet of the edge of a deal. They have to have a ground fault. Up until now, we haven't had that. They can be in the plug or they can be in the panel as a breaker, which is depicted here in this particular breaker. But we're going to have to start in residential in these devices. If it's built and comes under the 2020 code, then that 250 volt receptacle is required to have that. Now, some of the problems we're seeing are dryers. Some of the other appliances where the manufacturer put a bonding jumper wire from the conductor side to the cabinet. Then that means for this receptacle, the GFCI, to work on a 240, 250 volt, that bonding jumper has to be disconnected. And we've had issues with that where people complaining about their appliances not working now. So just keep that in mind. Indoor damp and wet locations have been added And Derek had mentioned a finished basement. Well, that no longer in the 2020 code, whether it's finished or unfinished, they have to have GFCI protection in damp and wet locations. And of course, basically what their code officials are telling me, and the studies that I've done, is the industry is going more toward you're dealing more with nonlinear loads than you are with linear loads, and these nonlinear loads they have put a tremendous amount of strain on neutrals, so we have to be careful of how we have the breaker sized, where we install the breakers and so forth, because it is causing havoc on the system. We're having to put other components in there to try to relieve that stress. So you think about a computer. If lightning or high static electricity, it can take a computer out. Well, on a home, most of your appliances now, especially the newer homes, they're all electronics. What we're talking in my office today, I've got 2 computers running. I've got digital this, digital that running, and it can cause you a lot of grief. So that indoor wet location, damp and wet location applies. Any outlet in a bathroom within 6 feet of a water rim, and that is not path of how the wires run. It is point A to point B. It is a straight one. Up until now, we've been able to route the wire to where it wasn't 6 feet, then okay. But now that definition has changed to where now it has, if I can take a 6-foot cord and I can plug it into a device and run it as straight as I can to it, regardless of how it's routed, and it's within 6 foot of a rim of a sink or bathroom, bathtub, shower stall, it has to have GFCI protection. Receptacles for the countertops, Derek spent quite a bit of time on that. Not everything, most everything is still about the same, except for the fact that receptacles for the countertops are treated differently than other receptacles. So you have to be careful, because sometimes the refrigerator needs to be a GFCI. If it's within 6 foot of that sink, it has to be. You can't have a plug below 12 inches of the countertop. It won't be considered as servicing the countertop. So in doing load calculations, that's what the electrician has to look for. Receptacles under sinks. Many circumstances have caused this to change and have them having to put this information in here, because people tend to lay plugs up, face up, and not put in devices that are listed for face up applications. So that's the reason that was added. Equipment requiring service. Any piece of equipment requiring service must have a lockout, tagout type device on it, and it must be able to be quickly disconnected. For example, a furnace, an electric air handler must have a disconnect at it. Now, it can be a mechanical device that is separate from the electrical circuit that the wires run through, like a disconnect, or it can be a plug, or it can be a switch where it can quickly be disconnected. They're not getting too strict on that, but it does, anything that's being serviced, you have to have, just like a refrigerator, of course, you pull it out, you unplug it from the wall, and you're good to go. Outdoor equipment outlets at 150 volts to ground and 50 amps or less. All of them have to have GFCI protection. Think about different heaters. Think about fountains. Think about all kinds of these gadgets, the fire pits that have electricity to them that automatically light. People have welders that they put in their garage. Those have to have, they're rated at the 50 amp. They have to have a GFCI. So those are things that you're going to be looking for under this section 210-0.8. as far as anything applied to electrical installation applied to the 2020 code. Other than dwelling units, appliances requiring service or maintenance, so it doesn't have to be a single family dwelling. It can be apartments, it can be hotels, it can be all of these things that we have to get involved with. GFCI is open at 6 milliamps. If you see something that's called a GFPE, Paul Edward, GFPE, it opens at 30 milliamps. The difference is this is allowed for outdoor equipment primarily on applications like boat docks and things of this nature. Cord length is 6 feet, and that's straight, as straight as it can be. And of course, they've limited going through doors and stuff like that in the code. So anytime that you can take a piece of a cord, a piece of rope, a piece of string, I don't care what it is, and you have one part of it on the plug or the GFCI receptacle or any unprotected plug, and you can reach the edge of the sink with your other arm. Typically our length of our span is 6 feet. If you can do that and go straight, that meets the criteria, the definitions of the code. So GFCI protection is promoted by NACHI requirements. In existing application where you have a two-prong situation where back in the 60s we didn't have grounded systems, we just had two-prong plugs, 50s and 60s. You could actually come in with a GFCI plug at the beginning of the circuit and protect everything downstream. So GFCI protection is allowed, and this is code. You can use this for code application. So whenever you do, if you need to protect those two-prong circuits, you can go in with GFCI and protect them that way, but you have to put in the three-prong circuit. So you're using conductors, the white and the black wire, the neutral and the ungrounded conductor. You're using the existing one, but you're having to put a three-prong plug in and add the bonding wire or grounding wire to that. It's just another way of handling it. Okay, arc fault, circuit interrupters. Now, a lot of you are probably already seeing the combination arc fault and GFCI breakers. In other words, a breaker senses the same current. What is happening with an arc fault and how it works is this particular one, if you'll see, you've got the neutral bus wire that's wrapped up and goes to the neutral bus, and then the neutral from the load comes into this screw and hooks in the black wire, or the ungrounded conductor hooks in. And what this electronic circuit is doing is reading static or reading spikes on the service on either the neutral or the black wire. Remember, the black wire has current going out to load. If the load is satisfactory, the same current's coming back in. So both of these wires should see the same current on alternating the circuits. Therefore, if it sees a spike, like lightning was to hit a building, or you have a chair sitting on a extension cord or cord under the floor or under the carpet even, this is where it's going to see it, because if that furniture moves or if there's an induced higher voltage to that circuit, you're going to have that particular situation seeing a higher spike. In other words, it could go up 2 or 3, some even up to 6 times what the voltage is. So that spike could be 600 volts. And we're only talking milliseconds. We're not talking, it's supposed to do or trip off according to milliseconds. What I am finding as an electrical contractor, if by using arc fault and GFCI, which the National Electrical Code is moving toward that, to where they have more of the circuits protected in the house to protect life and property. You're going to start seeing these nuisance trips, and I have a lot of them. I've dealt with 3 or 4 recently that is just like I can't solve the problem. I've done mega ohm, the circuit's good, all of this kind of stuff, but you put the breaker in and it keeps tripping. But in a combination, sometimes it will stay on for 3 days and then go off. Well, is that a power surge? Whatever. Just be aware that there's a lot of frustration with some of these circuits. But all of these breakers are very sophisticated and can sense things that we can't sense with just the normal instrumentation. We're going to have to up our grade, up our type of instruments that we use on circuits if we do testing. And of course, Derek mentioned about the test. These arc fault testing instruments are not the same as a ground fault testing instrument. And so if you have a combination, you got to have a different instrument. And I'll show you that instrument here in a little bit. Well, in fact, this next slide. So this is the instrument that we're talking about. This is combination. This is the first version of this is combination arc fault GFCI checking. It's also, manufacturers are having to have this writing on the plugs. So if you don't see that in the future, especially the newer homes, and it's not arc fault or GFCI, then there's a problem. And I'll show you another one where it's going to be an embossed type lettering, because why they've done this is because they can't depend on installers, service contractors, and electricians to put the proper labeling where they need to, or when the homeowner moves in, oh, I don't want that junk on my cover, I'm going to take it off. So they just peel it off. Well, now it's permanently ingrained into the device or embossed into it. So this will tell me that this is a combination arc fault GFCI receptacle, or the only test instrument is one similar to this one here. So these are basically introduced in 1999, and they are becoming more popular. In fact, back at that time, the only place that we had to put arc fault was in the bedrooms. So now it's evolved to where you have to put it almost everywhere you are, except for maybe wet locations. So I have a list here. If you notice, these are all of the words arc faults required: kitchen, family room, dining room, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways. You get the message. The jest is what they've added it to is guest suites and guest rooms. That means in hotels and so forth, guest cottages. A lot of these people are using these little mini homes to have little weekend getaways. They're going to have to start seeing arc fault in those patient sleeping rooms in nursing homes and guest suites. It's not required for branch circuit supplying and fire alarm. So GFCI and arc fault, you don't have to use it for fire alarm setups. Now, these are monitored type situations. I'm not talking about the normal plug-in mounted ceiling type that is either battery operated or not. I'm talking about the actual monitored equipment. You're not required to do that, because if there's a fault, it's going to kill the power to that device.
Ramey, we've got a couple of questions. You ready for some?
Yeah, let's break.
All right. One is 2-wire outlet replacements with GFCI and marked no equipment ground. Label requirements still okay, or must a grounding conductor be added?
Yes. You have to, under the current code, we have to put a label on that. Very few people do, But if we've replaced a plug downstream, you need a sticker on each of those. Now, is it enforced? No. So it's just a notation. I wouldn't call it a deficiency. If I can plug it into, if I can push the GFCI button and it kills everything downstream, then it's done its job. So.
Okay. All right. Next question is, what about redundant GFCIs or multiple GFCI outlets on the same circuit? Says he sees a lot on rehabs. All bathrooms need a GFCI, so let's put them everywhere.
Well, you better send a bottle of aspirin with it because it's going to cause headaches. No. If you don't understand the concept of GFCI or arc fault, if you're putting multiple devices, breaker plugs in the place of, and putting them in a single circuit, you have two GFCIs, there's no need for it. They're going to be bucking each other. They're going to be causing you headaches and so forth. So no.
Okay. Another one says, does a 6-foot rim also account for the toilet?
No. It only mentions sinks, lavatories, and bathtubs and shower stalls.
Okay. Another one says,
I hope no one's using one for.
Yeah. So if I understand this correctly, a dryer receptacle and an RV receptacle will now have to have GFCI protection effective November 1st.
Yes, if it's enforced. But yes, as far as the code's concerned, 2020 code, if I have a GFCI, if I have a, now we can be careful with this. If the RV is parked outside of a garage, then that does not require a GFCI. If the plug is in the garage and you're running the cord from that to then yes, it does require GFCI.
Okay.
Up to 50 amps. That's a little, I hope some of this stuff will be straightened out as we move forward because it's getting so critical that it's hard to understand. But yeah, anything, compressor, welder, I can't think of anything right now, but there's other devices that we all put in our garage, including RV units. Yes.
Okay. All right. Does the range need to be a GFCI if it's over 6 feet away from the sink? Since the range is located within the kitchen, wouldn't it need a GFI?
If it's a built-in, typically not. If it's a freestanding, which means it has to be readily serviced, then that is a code interpretation. And if it's not over 6 foot according to code, I'm not going to put one in it. But other code officials may say, no, you need to put that in there. You got to be careful. As an electrician, if I go into a different city, I'm going in and talk to the code official before I ever go wire, and those are some of the areas I talk about.
Okay. It says there is a newer GFCI device that is a delayed trip after testing it, approximately 2 to 3 seconds delay. Is this okay? Said he had a builder produce a letter from the manufacturer saying it was okay.
Yes, it is okay because typically it takes that long for it to happen, and if there's still the safety issue is still implied with that. Yes, but keep in mind GFCI, not GFPE. There's a difference there. And some people go to the hobby horse store and pick up a GFPE, not knowing.
Okay. Another question was, so are you saying that they need a transformer if changing or adding voltage device?
Repeat that, Paul. I mean.
Yeah, it says, so are you saying they need a transformer if changing or adding voltage device?
I'd have to have some clarification on that because typically you don't um, have to have add a transformer or anything like that. The example I gave earlier was just the way a typical underground system is installed.
Okay.
So I hope I didn't confuse anyone on that.
No, that's okay. Maybe he'll rewrite the question or reword it or something for us.
Okay.
Another question, last one I've got for you right now says, what's the new code on bonding of ground or grounding CSST?
Everywhere there's a manifold, a hard pipe manifold or a manufactured manifold, in other words, a block of metal that has drilled connection points and so forth, that needs to be bonded all the way back to the panel. And a lot of people are only bonding it where it enters into the structure. You go up in the attic and you've got 2 or 3 different manifolds and they're not bonded. And if something were to happen and that we've seen lightning hit a house and it just disintegrate the CSST, it left the manifold bare as far as ground fault protection. So you need a bonding wire going from terminal to terminal where the pipe comes in, where a manifold is. There needs to be a continuous bonding wire to that, back to the panel.
Okay, thank you very much.
Okay. So this is section 210.52, which deals with counters. And this is probably one of the most misunderstood. And there have been a lot of changes. As you notice, I'm reminding you, all of these changes on this slide have to do with 2020 code. So these are different than the other. I know Derek mentioned earlier about the rule for how close the plugs need to be as far as servicing the counter. That's been changed to the 9 foot, 9 square feet. So now instead of a distance, it's going to be square footage. So here's the rule. For the first 9 square feet, that means length versus width, I have to have 1 plug, 1 TSCI receptacle. And for the next 18 square feet, I have to have another plug. So now we're dividing, instead of running footage of the counter, how long it is or L-shaped or whatever the case may be, now it's defined in square footage because there's a lot of people. I've got one counter that is, I had to put 3 receptacles on to meet this rule, and you can imagine how big that was. It had the sink in it. So anyway, you have to pay attention to that. One receptacle must be located within 2 feet of the outer rim of the peninsula. Okay, so whenever you see the peninsula, which is a peninsula is defined as an extension of a countertop that is perpendicular to the main counter and is less than the counter width, then you have to have a receptacle within 2 feet of the end of that peninsula. And then multi-outlet assemblies are considered one receptacle outlet. So in other words, if you're seeing devices like you see on this slide, where you have 2 receptacles right here, they're considered multiple outlet assemblies are considered one receptacle outlet. I know sometimes I'll go in and I become wiring a house anymore. I don't put single receptacles in here. I do duplex. In other words, I have 4 plugs in one location. Like for this counter space right here, I would have 1 duplex. For this counter space, let's say that the cooktop is here, I'm going to put 1 duplex here and I'm going to put another duplex on the other side. You can't have enough plugs anymore because there's homeowners they have these smell good things that take up a plug, the oils and stuff that odorize the air. appliances are becoming more prevalent. It's just like this device right here is a pop-up on a countertop. These two are listed as it shows here. They must be listed for their usage. This one has USB connections within the plug. You're starting to see those a lot, even in furniture. Recliners, they've got plug-in device to electric motor on recliners. It has USB connections onto it. So these are all pop-up type deals that you can push down into the counter, and they meet the requirement of the code. Receptacles cannot be installed more than 20 inches above the counter or work surface. So it doesn't, if it is, it's not part of, it doesn't meet the code requirement for being a counter type plug setup. The next one is the countertop and work surfaces receptacle outlet assemblies listed for use. I've mentioned that, those two pictures at the bottom. And then receptacles located underneath the counter area that extends more than 6 inches is not considered a required countertop surface. So that has changed from the 12-inch rule to the 6-inch rule. So if I put one that's more than 6 inches, like if I put one down in this area, that would not mean that it services as a counter. I know a lot of times instead of buying these expensive devices, I go to the edge of the counter. If I have the space available to where I can put a box and run the wiring to where I don't have to cut into that countertop, because these granite and marble countertops, they're very delicate and they can cost you a lot of money if you were to break them up. So you're going to see a lot more of these on the side. You're going to see a lot more people using some of these devices to their attitude of homeowners right now is keep the houses clean, clean looking, clean cut, and so forth. Okay, this is the 21052 is outdoor receptacles. A couple of items that here it says that there's an exception where a receptacle outlet is not required in a garage space not attached to an individual dwelling unit of a multifamily dwelling. So if there's a garage, say typically a one-car garage is a multifamily or a duplex, and that garage is attached to the building, to the structure, to the dwelling, then there's a plug, one GFCI plug required. And furthermore, that GFCI plug must be 20 inches off the ground. That came in 2017. So those plugs must be at least 20 inches off the ground to the base of those if they're in the garage. However, if you were in a condominium or a duplex and the garage was remote, it does not require a GFCI in that situation, especially in multifamily. The next one is a receptacle is required in each vehicle bay of a garage with electric power and must be installed no higher than 5 foot 6 inches above the floor. So in other words, if you have a 2-car garage, you are required to have one particular GFCI power within that space. 3-car garage means that I have to have 3. The other thing is that it has to be 20 inches minimum off to the bottom of the receptacle, and you can't have it more than 5 foot 6 inches above the floor. That also says that in the situation that you're going to have a GFCI receptacle for garage door openers as well. In the past, we haven't had to have those, but now they're calling for those. And let's see, a receptacle is required in an accessory building with electrical power. If you have remote buildings on your property, if there are remote buildings on the property, and there is power to that building, then you have to have a GFCI receptacle. You have to have a receptacle in that building. So those 3 things have been changed in that particular section. Of course, we've been harping on this for years, 21063 is equipment requiring service. There's a lot of emphasis going forward that everything where there is service, there's going to have to be lockout, tagout. In fact, even in electrical panels, they're requiring those service type breakers to have lockout capability. And that is either locking the door of the panel or it's locking a particular device within the panel. It meets that requirement. The other thing is the required receptacle is not allowed to be connected to the load side of the heating, air conditioning, and refrigeration equipment disconnecting means. And that has, Derek talked about that. And that is something that this is just an expanded definition, not a definition, but an expanded description of what we're supposed to be doing. And, you know, in the beginning days when I was just learning electricity, I'm as guilty as anyone was to take that 220 and hook that neutral to ground. What is it? I mean, they all go back to the same place, right? That's the most dangerous thing that we could do. It is just now, let's see, it's been 2017, 2014, and maybe one code back 2011 may have started requiring receptacles at air conditioning units. The limitation is service now is 25 feet and within sight. That is 20. If I'm standing at the unit, now clarify, if I'm standing at the unit and I look in any direction from that unit within 25 feet, there must be at least one receptacle dedicated to the service of that equipment. It can be an outdoor receptacle. It could be a patio. It could be a receptacle on a patio, just as long as it's within the 25-foot rule and I can see it from the where I'm standing at the unit, I'm good. But the thing is, it can't be, you can't use unless you have 4-wire service, and really not then, because you'd have to have a circuit protection, overload protection for the circuit. But each one of them needs to be, that needs to be GFCI protected. The disconnect for the air conditioner, there is a, I don't know if I get to it yet, but there's a clearance rule that you have is 30 inches on each side, or 30 inches and 3 feet away. So if that disconnect is located behind the unit and you got to squeeze in between to get to that, that is a violation, and has been a violation of the code for at least 4 decades, at least for 4 code changes. The last one here is the required receptacle outlet must be located on the same level as the equipment, and it is not permitted to be connected to the load side of the equipment's disconnecting means. There are a lot of rooftops, and again, this more is stated more in commercial equipment than it is residential. However, places like Phoenix and Southern California and places like that, most of the units are located on the roof. They are now have added in the code language that the outlet, you must have an outlet on the same level. So if your condensing unit or rooftop unit or package unit is on the first floor or up on the roof of the first floor, you must have a plug within the 25 foot or within sight of that. So that's an added explanation to make sure that people completely understand. And the outdoor, this is right here is where I was talking about the outdoor receptacle on the patio. If it's within distance 25 foot of the unit, you're okay with that. That meets the requirement. This is lighting outlets. A lot of people have motion sensors, especially in some office buildings and so forth that I get involved in. But motion sensor devices for places like this is they must either have an additional control device, or they must have on that a particular switch that will short circuit the motion because these the technology in these particular switches is sometimes hasn't been the best and dependable as you can see. So they're requiring either have the switch here or have a switch beside it that can turn it, override it. And let's see, device, this is a comment in the code that they've added: a wall-mounted control device behind the door is not an NEC violation. The wall switch is, you got to be able to see, you want to be going into a room, you want to be able to turn the lights on as soon as possible. But the control wire, this override or this wall, the switch turning the lights on or off, doesn't have to be at that level. So therefore it would require a sensor, number one is what we call it, and the switch at the door. And you must have at least one listed lighting outlet controlled by at least a listed wall-mounted control device. It must be installed in every habitable room and bathroom. What the code is trying to do is get away from those homes that still are using pull chain lights in the center of a room. And I know there's not that many of them, but there still are some out there. And there's some out there that are still wired. I see them not as often as I used to, but I still see homes that only have one plug, one 2-wire plug, a knob and tube wiring, and they have a switch or have a light in the middle of the room with a pull chain on it. There's no wall switch on it. So that's what they're trying to get away from is the physical damage that it can cause. Okay, this is new. This is one of 3 things, if I remember correctly, one of the 3 things that are really going to change our industry, if you will, is surge protection devices. Section 230.67 through 70 is surge protection is starting to be required on residential buildings, on dwelling units with surge protection. Now, there's multiple ways to do it. This particular one is a meter mounted device, and if you're dealing with the utility company, you have to check with them to see how they're doing it. Some utilities are letting this device be mounted, or others are requiring that they mount it because they don't want anyone tampering with the meter. In fact, it's federal law if you tamper with a meter. The other way is a device that is internal in the cabinet to where it can be wired into the panel board and controlled by the backfeed breaker, or what they call the control breaker. The other device could be something that mounted remotely. This type device can mount remotely. But what it says in the instructions is it must be as close to the panel as possible. In other words, they want the shortest distance of wire and the straightest run as they possibly can. So these are things that are coming. These are things that are starting to be required, and depending upon your municipality, whether they will require them this year, next year, or even later. Again, 2020, as far as state code is concerned, was activated in November. So the surge protection is because of this thing that that we've seen for years with the neutral loading up, and we're having to oversize the neutral to compensate for nonlinear loads. So these are things that we deal with. A note here is to refer to Article 240 for over voltage protection. And it's just some additional reading if you want to get into it. But this is a new deal. It will be required on all services going forward. It is, I haven't gotten clarity, or I haven't seen or heard clarity if you have to change out of service if they make you do this. So we'll see how that goes when we move forward. Okay, service disconnects. It's kind of getting an idea when you're looking at a main disconnect if this is another biggie that's coming forward. These wires right here, they're coming straight off the meter. These are the ungrounded conductors and the grounded conductor and the bonding jumper right here in the equipment grounding conductor, or the grounding electrode conductor right here. That's called the service entrance, and that's where service entrance stops. Everything else is either a feeder or a branch circuit. So you have to be careful when you're looking at these. And each service must have only one disconnecting means, except as permitted by 230.71, which allows up to 6 disconnecting means on one service. But what they want is to have those literally not in the same panel. We've done it as electricians. We've had our main, and then we had 6 breakers in here, and that's met the requirements. But now that's not the case as the new rule is going forward. So with that said, here's item number 2 that you have to be aware of is now the old rule. Now you have to have an external disconnect for, it's not part of the service equipment. It's more of a safety for emergency use. It's called an emergency disconnect. This is one particular application, but it must be on the exterior of the building. And now it's required in 1 and 2 family dwellings. So we're going to start seeing that as we move forward, as the utilities require the municipalities to provide these. I've understood this for a long time. The code says you've got to have the main disconnect for service as close as possible to service. So they've allowed us to put the panel directly on the backside or just adjacent to the meter base. And that's been satisfactory, but it's been locked up in a garage, or it's been in the middle of a house, or whatever the case may be. Now they've gotten to the point that they're thinking about or trying to carry forward with this emergency disconnect. It does not serve as any means of protection other than to disconnect the service to where fire people or someone else is working on the service in a safe manner, and keeping it's another reason to keep people from pulling the meter. So, but it is considered part of the service equipment. So, but it has to have labeled, and if you notice down here, the labeling has to be embossed such that it won't go away. In other words, it can't be just a sign, because the lighting, the infrared lighting will cause it to erase. So it has to be either embossed or in a type of ink or something. It's a permanent sign attached to this particular device. This is, I've mentioned this before, is a 240/24 panel locations. This has basically been the same as we've talked in several years. It has to have, and this is the reason we had to move panels out of closets, because we didn't have the work area around these. But 30 inches, 36 inches, and 6'7" is the no man's zone. In other words, nothing can be in front of that panel, period. I have a lot of issues with commercial buildings on this, but if you've got panels in basements, they're wanting you to elevate or protect or isolate the moisture that can get in a panel. Derek had some pictures in his presentation where water and corrosive or poisonous corrosive gases such as chlorine gets into these panels. Water is terrible. Water gets into these. You see these panels that are mounted on the outside, and they just start rusting over a period of time, and can cause loose connection, can cause shorts, all of those things. So they're wanting to see this type of application going forward. Okay, I think this is a good time for us to, I'm going to pause here to ask some questions if you have some questions.
Yes, sir. Let's see if we can get some of these questions pulled up. And if I ask you one that we've already asked you, I know I have one here that says a bidet attachment on toilet doesn't need a GFCI. That is a question.
As an electrician, if I were to go in and I was hooking up a bidet, I would treat it just like I would a pet washing, yes.
Okay. Next question is, what about a GFCI in a bathroom that turns out the lights when tripped?
Yes. Every bathroom is required to service a sink, service the lavatory. It's required to have one at each one, as long as it's 6 feet away from a tub, and there's code language that says if it's a small bathroom and all you have is a tub or shower and commode, then you have to be on the opposite wall. Which means you could be closer than 6 foot. That's the only time that I'm aware of that the code allows that GFCI to be closer than 6 feet.
Okay. Another question is, there is some controversy about the AFCI GFCI combination receptacle. While it protects itself and downstream receptacles, what happens to the circuit between the panel and the combo receptacle? Is it considered protected?
No, it's downstream. It's not upstream.
Okay.
But the code allows for that circuit to go to the closest combination receptacle to the panel. You can't go to the furthest and work your way back. You have to be as close as that circuit allows.
Okay. Another question is, please answer this. With the new requirements in Article 210, branch circuits, shall we call out in new construction? A builder may say they are not required to update the circuit because it's NEC correct.
If it is NEC correct and that there has to be modification or the circuit is intended to have to be extended for whatever reason and I understood the first of the question being new construction, but if a circuit is already there and a homeowner wants to extend that circuit, you're going to have to put a GFCI in that extension. You don't have to go back to the older, especially if it's the 3-prong or the standard grounded type devices. But if you add to it, yes, you're supposed to do that. Now, if you go more than 6 feet, that's the rule in the code that says if you go more than 6 feet, then you're going to have to consider a new circuit, which will require you to have an updated circuit. So anything, and this is one thing I don't understand, is the code does allow, if there's damage, storm damage, lightning damage, somebody runs into the structure and you have to, as an electrician, I have to change the meter base. Do I have to upgrade everything? Code official usually says no. If you're only doing repair from damage, you're okay to go back in with the existing, but the meter base and all of the pertinent wiring service entrance conductors have to be up to code.
Okay. Another question. It looked like the emergency disconnect was locked in the illustration. This doesn't seem right.
Right here?
Yes, sir.
That's locked in the on position. I'm sorry that wasn't really clear, but what that is kind of like, well, it is what it is. It's only for emergency personnel only. So in other words, it's like a device that we have on commercial buildings for the fire department. Instead of having to use their axe or hammers or tool and damage the building, now all they have to do is have a standardized key and they can open this, just like realtors have standard keys or have standard passage, so they can disconnect the meter. So basically, once it's put in, the electrician won't use it unless they have to change the meter.
Okay. Next question is, please clarify, the 30 by 36 by 78 inch rule does apply to air conditioning boxes?
Yep. Yes.
Okay.
Anything that's an electrical device, it has to be worked on. It's just like I've got a situation in the church right now where I have a panel, a setup for that has all of the devices located in that panel or device. You even have to have that clearance around that.
Okay. And then we have this question. Is there a rule prohibiting the installation of a light switch behind the door, such that the door must be closed to reach the switch when entering a room?
Yes, there is. I'd have to look it up to get the exact reference. The was mentioned there before are the devices that have automatic on and off lighting, can be placed behind doors.
Okay, that has answered all of our questions that has come in. We have about 7 minutes before the end of our class. Ramey, would you like to just discuss any of these, or do you have more presentation that you'd like to offer?
I have some more presentation. I would like to get through the grounding portion because that seems to be the most misunderstood for electricians, code officials, everybody, all of us included, is understanding the terminology and being able to speak to it and understand that you can't use a grounding conductor and so forth. So I'd like to spend a little bit of time on that and then talk about any other elements that people want to talk about.
Okay, I think we're good. Because you'll be the last class for the day, I think we can allow that little bit of extra time. At 3 o'clock, we have a raffle. So go ahead, Ramey. Let's see. I know these guys are waiting to hear you.
Okay, so I'm going to say 2:45. Is that a hard break?
Yes, sir. You can go with 2:45, or if you need 2:50, I think that they would agree that they would want to know this information.
Okay. What I have. Attention. This is Sarah Cello with the Council Services. Forgot to get the phone out here. Apologize. Equipment grounding conductor, grounding electrode conductor, and bonding, all of those are different and separate. We mentioned, or Derek mentioned about this device right here, which is can be attached to the building or can be attached to the equipment grounding, the grounding electrode conductor for utilities to ground to. I know that in the past, they have used straps, they've used all kinds of mechanisms to ground, but we have to also be sure that everything in the building that is associated with the building, as far as water, gas, anything else, has to be bonded back to the service. The equipment grounding conductor, the grounded conductor, if you will, the neutral, is the only bond that takes all of the faults back to earth. And so everything else has to be bonded, including there's some things on service entrance. Derek mentioned those, where on service entrance conductors, you have to have the connector has to be bonded. You don't have to have it past that on the feeders or the branch circuits. You don't have to have that, and so forth. So just clarification on this. This is an acre nut on the grounding electrode conductor that goes to this. The code now requires 2 8-foot grounding copper 5/8 rods to be driven in the earth, or can be in concrete, but it has to be driven vertically into the earth and this wire has to be continuous. The coding right now, or the interpretation of the code official, is it's a series setup. So this would be one rod, and 6 foot down would be a second rod. So this wire can't be cut. It's not supposed to be cut, and it's supposed to be under an approved acorn type or some other device approved for ground electrode excuse me, grounding electrode conductor. It's getting very complicated. This is not good. These are pictures that have been, you see, circulated sometimes. Even this twisted wire here doubled up under this terminal is improper. You cannot have more than one wire under a terminal unless it's listed for that. So therefore, it has to be listed and has to be notarized and noted as it says in the new code. The manufacturer has to put on this what the torquing is under that wire. So, but wiring has to be marked. Anything larger than number 6 wire, larger than number 6 has to be marked, because typically you only buy that as a black insulation. Anything less than that, you can buy number 6 as a green or different colors if you want to. So that's part of the code as well. The neutral bus, or neutral bonding, if you will, this is a meter base. This is a service disconnecting means. This is called service equipment. And whether it's outside or inside, this screw has to be in place in this neutral to bond the can to the neutral, or to the grounded conductor. And if you notice, you've got your electrode to your grounding electrode conductor is there. This is just another particular one to where all your service equipment goes into here. If this is your main, then this is service equipment. If it comes straight from the meter, that means that has to be bonded. There's another thing that I talked about about the 2017 code, where these are eccentric or concentric knockouts, and you're not in the last one, then you have to have that bonding there as well, that would attach to the cabinet or to the bonding bus. Now, the new panels that are coming out, you're going to start seeing them. In fact, right now with Cutler Hammer is my first experience. That's what I use is breakers. You're going to see where the neutral conductor is no longer. You may see the grounding bus, but the neutral conductor is part of the built-in breaker. So it matches to it. I can't even, with Cutler Hammer, I've got to go and buy a specific breaker and order it. So now they're coming, the new panels have a little bit more room. They have the breaker has 2 contact points, or actually 3. One's a mounting point, one's a contact to the ungrounded conductors, and then one's a contact point to the ground dead conductor. And what they're trying to do is clean up some of these messy panels and meet the rule requirements, or the requirements for filling those panels. So this is the meter base. This is where that you would have to have a bonding conductor. This is the service entrance. Well, this is service entrance here. You would have to have bonding here. You do not have to have bonding here, because these are feeders. You have to have the bonding screw here for the main, but when you go past the main, then you have to separate the neutral and the grounding conductors. So basically that's what it is. The centric that I talked about are concentric or eccentric. If you haven't knocked out all of those, then they have to have a bonding type bushing on those conductors coming in. And of course, the grounding electrode conductor coming down, if it's in conduit, because it's required to be protected, then if you have conduit or any type of piping, preferably the conduit, the metal, which can set up a magnetic field, you have to bond those, and they have special fittings for those to where you can bond them out. to where you have zero plane between this part and this part. That's what the main reason is for that. And that should do it, Brenda. Any questions?
No, I think that was our questions that we had. Let me double check real quick here.
Okay.
I think you clarified the clearance for an air conditioner for the disconnect, didn't you?
Yes. Yeah, it was in the up position, I think is the one that you were referring to.
No, the question was about the clearance, the 30 by 36 inch clearance, and that does apply to a disconnect on the AC, even
Yes.
though we seldom see that in real life.
You do, but that's the main reason we keep reinforcing it, because that's been in several code changes, and it just, people just don't understand that I'm going to sit on the air conditioner and work on the disconnect. That doesn't even make good sense. So it's got to be outside of that area, or the condensing unit has to be moved away to where there's that 3-foot rule.
Correct. All right, Ramey, I think you did a great job, buddy. We appreciate it. I'm gonna let Brenda come back on.
Okay.